Welcome to our online chemistry class. Myself, KHARGE from SS Famous and Junior College, Shivajinagar, Pune 5. Our topic is electrochemistry. Let us discuss next part, that is part number 5. So, in this part, we have to discuss electrode potential and cell potential. So, galvanic cell is composed of two half cells, each consisting of electronic metal plates and electrolytic solutions or electrolytic conductors in contact. So, at the surface of separation of solid metal and its solution, there exists a difference of electrical potential. Okay, and this potential difference established due to the electrode half reaction occurring at the electrode surface is the electrode potential. So in previous video we discussed the Daniell cell. In that Daniell cell, one electrode acts as an anode, which is written on left hand side in the formulation, and another electrode which acts as a cathode, which is written on right hand side. At anode, oxidation reaction takes place. In Daniell cell, zinc solid gives Zn2 plus 2 electron, and at cathode, the reduction half reaction takes place. Cu2 plus gain 2 electron gets converted to Cu solid. And what is the combination of these two? That is the redox reaction, which is the overall reaction of the cell. Zinc solid plus Cu2 plus 1 molar gives Zn2 plus 1 molar plus Cu solid. So these are the reactions in Daniell cell. So a zinc rod dipped in ZnSO4, copper rod dipped in copper sulfate solution, and the potential across that each electrode is nothing but the electrode potential, and the overall potential of the cell is called as cell potential. Okay, so the potential is associated with each of the halves reaction just now we discussed, and it is oxidation or reduction. The potential associated with oxidation reaction is called as oxidation potential, while that associated with reduction gives the reduction potential. So oxidation potential is the potential of anode and reduction potential is the potential of cathode. And the overall cell potential is known as electromotive force or EMF. And EMF is made up of the contribution from each of the electrodes. In other words, the cell potential is also known as electrode potential, algebraic sum of electrode potential, that is denoted by E cell, and it is equal to E oxidation at anode plus E reduction at cathode, where E oxidation is the oxidation potential of anode, which is negatively charged, and E reduction is the reduction potential of cathode, which is positively charged. Then I will represent the overall formulation by using the word LOAN, lone. It means L for left, O for oxidation, A for anode, N for negative. So left hand electrode is anode, which is negatively charged, and at that electrode oxidation takes place. Opposite to that is right hand side, where reduction takes place. It is known as cathode, and which is positively charged. Now when galvanic cell operates, the electrons are generated at anode, and these electrons move through the external circuit to cathode. So here you can see the electrons are generated by nickel. So nickel gives Ni2 plus 2 electrons, and these 2 electrons pushes away from that anode and pulls them towards the cathode. Here Al accept that electron. Okay. Now next one is the standard potential. The electrode potential and the cell potential depends on the concentration of solution. If it is aqueous solution, if it is in gaseous state, then pressure of that gas is considered, and you have to consider also temperature. To compare the different types of galvanic cell, it is very necessary to measure the cell voltage or cell potential under the given set of standard condition of concentration and temperature. So all are familiar with the STP word. Similar type the standard conditions are maintained. So standard condition chosen are 1 molar concentration of that solution if it is in liquid state. If it is in gaseous state, then you have to measure the pressure, which should be 1 atm, and if it is solid and liquids in pure form and temperature is 25 degrees centigrade, then that condition is called as standard condition, and the potential or voltage measured under this condition is called as standard potential. It is represented by E0. Okay, 0 is at the power. Okay, it is superscript. The standard cell potential is the algebraic sum of the standard electrode potential, similar to the previous equation. So E0 cell is equal to E0 oxidation anode plus E0 reduction of that cathode. Now E0 oxidation means it is a standard oxidation potential. E0 reduction means it is a standard reduction potential. So according to IUPAC convention, standard potential of the electrode is taken as standard reduction potential. Always you have to consider the standard reduction potential to make the equality. So it must be realized that the standard oxidation potential of any electrode is numerically equal, but its value is reverse. So we have to change the sign. If it is minus in case of oxidation, if you have to write its reduction potential, write down it plus. For example, oxidation potential of Zn2 plus 1 molar influence of zinc electrode, that is zinc dipped in Zn2 solution, its oxidation potential is 0.76 volt. So what is the standard reduction potential? It is minus only, but value remains in 0.76 volt. So hereafter we consider the standard reduction potential is called as standard potential only. The reduction word is not used, and that is the voltage associated when reaction is reduction. So always we consider the reduction reactions. So it follows that standard cell potential, that is EMF, can be written. So in previous equation we change the E oxidation at the anode by E0 reduction by changing the sign. So what is our equation becomes? Our equation becomes E0 cell is equal to minus E0 reduction. In previous equation here the word oxidation, so plus is the sign. If it is reduction, then change only the sign. Minus E0 reduction at anode plus E0 reduction of that cathode. So now both the reduction potentials are taken, so we omit the subscript RED word. So your EMF of the cell is nothing but E0 cathode, which is positively charged, minus E0 anode, which is negatively charged. So hereafter we use only reduction potential. Okay. Then next is the dependence of cell potential on the concentration, and it was proposed by Nernst scientist in his Nernst equation. So let us see what is that equation and how we calculate the cell potential. The standard cell potential tells us whether or not the reactants in their standard state form the product in their standard state. Whether that reaction is carried out or not in spontaneous way, that is understood under this heading. So to predict the spontaneity of reaction for anything other than standard concentration condition, we need to know how voltage of galvanic cell varies with concentration. So for that purpose, we have to consider general equation for the reaction. Here, the dependence of cell potential on the concentration is given by Nernst equation. So the cell potential is given by, what is the formula? E cell is equal to E0 cell minus RT upon NF. Ln means log to the base E. There is a ratio of concentration of product raised to the stoichiometric coefficient divided by concentration of reactant raised to the stoichiometric coefficient. If there are more than one product, then there is a product of concentrations. Here two products are there, C and D, and two reactants are there. So Ln, concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A into concentration of B raised to B. Now here we have to change the base from log to the base E to the log to the base 10. Multiply this equation by 2.303 in the respective term. What is your equation? E cell becomes E0 cell minus 2.303 RT divided by NF. Now base get changed from log to the E to log to the 10. Remaining things are same. Concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A into concentration of B raised to B. This equation is the Nernst equation. Here N is nothing but moles of electrons used in the reaction. So how many electrons are transferred during that overall reaction, that you have to write here. F is nothing but Faraday, 96,500 coulomb, 1 Faraday. Then temperature is the T in Kelvin, don't take in degree centigrade. R is the gas constant and its value is 8.314 joule per Kelvin per mole. Now if we substitute the value of R as 8.314 and temperature, if it is in degree centigrade, is 25, that means in Kelvin it is 298. Add 273 to this, it becomes 298, and F means 96,500. So 2.303 RT upon F means 2.303 into 8.314 into 298 divided by 96,500. The answer is equal to 0.0592 volt. Okay, if you substitute this term in the previous formula, then our formula at 25 degrees centigrade becomes E cell is equal to E0 cell minus 0.0592 volt divided by N only into log to the base 10 of product of concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A into concentration of B raised to B. And this equation also called as Nernst equation. The first term on the right hand side of this equation, this one E0 cell, represent the standard state electrochemical conditions. That means the electrode potential when standard conditions are there. Just now we discussed that standard condition, concentration is 1 molar, then pressure, if it is in gas state, then 1 atmosphere, temperature is 25 degree. Okay, then this is the value. But the second term is the correction for non-standard state conditions. So if temperature is different, then there is a correction for non-standard state, and the cell potential equals the standard potential if the concentration of reactant and products are 1 molar each. So thus, if concentration of A is equal to concentration of B, which is equal to concentration of C, which is equal to concentration of D, and if it is equal to 1 molar, then E cell is equal to E0 cell. So if gaseous substance is present in the cell reaction, its concentration term is replaced by partial pressure of the gas. So the Nernst equation can be used to calculate the cell potential and electrode potential. So if partial pressures are written here, instead of A in the square bracket, write down PA, here PB, here PC, and here PD, and substitute these values in the previous formula. It becomes the Nernst equation. Then calculation of cell potential. Consider the cell CD solid, single vertical line means that electrode is dipped in its aqueous solution CD2 plus EQ. Here copper dipped in CO2 plus aqueous solution. In these two cells, which are the half cells, they are connected through solid bridge denoted by double vertical line. So let us find out the reactions carried out in this cell. So again, you have to remember the word LOAN, lone. So here left hand side is the anode, which is negatively charged, and here oxidation takes place. So CD solid gives CD2 plus, okay, CD2 plus. So here CD2 plus is formed by the loss of 2 electron by the cadmium. So loss of electron, therefore oxidation, and these 2 electrons are gained by Cu2 plus. So Cu2 plus aqueous plus 2 electron gives Cu solid. So gain of electron means reduction. So it is very easy to write these reactions. Remember word lone. On left hand side electrode, oxidation takes place. Start with this CD and convert that into this ionic form. So CD gives CD2 plus. So what is the difference between them? It is plus 2. So that was removed by removing the 2 electron. Then second reaction is start with this aqueous solution ionic form and into neutral atomic form. So Cu2 plus gets converted to Cu. So on left hand side plus 2, on right hand side is 0. So how will you equalize that? By adding minus 2 to left hand side. That means you have to add 2 electrons. Minus 2 means 2 into minus 1. Minus 1 means 1 electron. And if we combine the oxidation half and reduction half, then we will get overall reaction. So this CD solid plus Cu2 plus aqueous, these 2 electron and these 2 electron get cancelled. On right hand side CD2 plus aqueous plus Cu solid. This is the overall cell reaction. Now you have to calculate the EMF of the cell. How many electrons are transferred here? 2. So N is equal to 2. And the potential of the cell is given by Nernst equation. So E cell is equal to E0 cell minus, so we suppose that temperature is 25 degrees centigrade. So here 0.0592 N is equal to 2 log of concentration of the CD2 plus, here product is CD2 plus aqueous, but copper in solid state, so it is considered that its concentration is 1 divided by concentration of reactant is CD solid, therefore its concentration is 1 into concentration of CO2 plus aqueous, it is written as it is. So concentration of solids and pure liquids are taken as unity. So this is your final equation. Simply substituting the value of E0 cell, concentration of CD2 plus and CO2 plus, then we can calculate the EMF of this cell. Next point is thermodynamics of galvanic cell. So gives energy of cell reaction and the cell potential. So electrical work done in galvanic cell is the electricity, that is charge pass multiplied by cell potential. So electric work is equal to amount of charge pass into cell potential. Charge of 1 mole electron is nothing but 1 Faraday. Okay, and unit is coulomb. 1 Farad is nothing but 96,500. For cell reaction involving n number of moles of electron, so for 1 mole electron the charge is F. For n number of mole of electrons, charge is n into F coulomb. So hence the electric work is equal to n into F into the EMF of that cell, so E cell. So W gives in 1878 concluded that electrical work done in galvanic cell is equal to a decrease in Gibbs energy. So if it is decrease, then we write with negative sign. So minus delta G of that cell reaction, and it follows that electrical work is nothing but minus delta G. So if we equalize the right hand side, then what we get? Minus delta G is equal to NF E cell. So transfer this negative sign to right hand side. So delta G is equal to minus NF E cell. So under standard state conditions, we can simply write down the 0 as its superscript. So delta G0 is equal to minus NF E0 cell. So equation 5.27 and 5.28 explain why E0 cell is an intensive property. The property which depends on amount of substance is extensive property, and if it is not depends on the amount or quantity, then it is intensive. So we know that delta G0 is an extensive property since its value depends on the amount of substance. So delta G0 is extensive, but E0 cell is intensive. If the stoichiometric equation of redox reaction is multiplied by some number, let us suppose here multiply by 2, that is the amount of substance oxidized and reduced are doubled. So delta G0 becomes double. The moles of electron transfer also double. If we multiply both this oxidation and reduction by 2, then number of electrons also become 4, and we can write 2 CD solid plus 2 Cu2 plus gives 2 Cu CD 2 plus 2 Cu solid, and number of electron transfer also becomes double, so becomes 4. So what is our E0 cell? So E0 cell is equal to minus delta G0 upon Nm. Initially, now we have to multiply here delta G0 by 2 because Gibbs energy is an extensive property, it becomes double, and number of moles of electron transfer is also double, so it is 2 into Nf. So 2 to get cancelled, delta G0 of Nf is the same value. So E0 cell is the intensive property. Remember this, delta G0 is extensive but E0 cell is intensive. Remember this hint, for chemical reaction to be spontaneous, delta delta G must be negative, then reaction is spontaneous, and because delta G is equal to minus NF E cell must be positive. So if E cell is positive for a reaction, then it is spontaneous. Now, standard cell potential and equilibrium constant. The relation between standard Gibbs energy change of cell reaction and standard cell potential is given by, in this equation, minus delta G0 is equal to NF E0 cell. The relation between standard Gibbs energy change of a chemical reaction and its equilibrium constant K is given by, in thermodynamics, it is equal to delta G0 equal to minus RT ln K. Okay, so you can see this equation 5.29 in thermodynamics on page number 85. So if you combine equation 5.28 and 5.29, then what we get? So if you combine these two equations, minus NF E0 cell is equal to minus RT ln K. Okay, so if you simply rearrange this equation, what we get? E0 cell is equal to minus minus become plus RT divided by NF into ln K, and if we substitute the ln by log to the base 10, then multiply the term by 2.303. So our E0 cell becomes 2.303 into RT divided by NF into log to the base 10 K. Okay. So remember these formulas. Now let us discuss some numerical based on this. Let us discuss the numerical. First numerical is, write the electrode reaction and net cell reaction for fuel cell. So calculate EMF of the following cell at 25 degrees centigrade. The cell is Daniel cell, zinc solid in presence of Zn2 plus aqueous, and this half cell is in contact with another half cell with salt bridge, and the second half cell is Cu solid in presence of Cu2 plus aqueous. So your complete cell is Zn solid in presence of Zn2 plus aqueous, which is in contact with Cu2 plus aqueous in presence of Cu solid. So standard reduction potential, that is SRP, of zinc and copper are minus 0.763 volt and plus 0.334 volt respectively. This numerical asked in October 13 for 4 marks. So let us discuss the solution. Which are the given things? So remember that left hand side electrode is anode and right hand side is cathode. Our hint is lone. So zinc is the left electrode, so it acts as anode. So E0 anode means standard reduction potential of anode is given minus 0.763 volt, and that of cathode is right hand side electrode copper 0.334 volt. Now we have tried the electrode reaction. So let us discuss the lone word LOAN. Left electrode is anode, which is negatively charged, and oxidation takes place. Start with zinc solid and end with Zn2 plus aqueous. So zinc gives Zn2 plus aqueous. So zinc is 0 and Zn is 2 plus on right hand side. So 0 gives 2 plus means when Zn gets converted to Zn2 plus by loss of 2 electron. So loss of electron means oxidation at anode. So this is a reaction with the reduction potential. While the another reaction is Cu2 plus get converted to Cu0. So 2 plus, here it is 0. So if we make left hand side also 0, make left hand side is equal to 0, then you have to subtract 2. So subtract 2 means you have to add 2 electrons. So Cu2 plus 2 electron gives Cu. That is the gain of electron is reduction at cathode. Here is the reaction with respect to reduction potential. So combine these two, Zn plus Cu2 plus 1 molar, 2 electron get cancelled. On right hand side product is Zn2 plus 1 molar plus Cu solid. So this is the overall cell reaction. And what is the EMF of the cell? EMF of the cell is nothing but what is the formula? E0 cathode minus E0 anode. So that is the cell potential. Substituting these values, what we get is equal to plus cathode is 0.337, sorry it is 334, make it correct, minus 0.763. okay, and if it is 7, in some book it is 7 is printed in old syllabus, so answer is 1.1, but if you write here 4, then so it is 0.334 and your answer is 1.097. okay, it is approximately equal to 1.1 volt. So let us discuss the next numerical number 2. Calculate E cell and delta G0 for the following at 28 degree centigrade. So equation is Mg solid plus Sn2 plus molarity is 0.04 molar gives Mg2 plus 0.06 molar plus Sn solid, and standard reduction potential of the cell is 2.23 volt. Is the reaction spontaneous? That you have to check. Now while solving this numerical, what is the given thing that we have to see? Let us discuss solution. Given is standard cell potential is given, E0 cell is equal to 2.323 volt. Now it is not necessary to write the oxidation and reduction reaction, but to identify the n value we must familiar with how many number of electrons are transferred. So for your understanding purpose I have given these reactions. So what is the oxidation at anode? So let us identify the two changes. Mg gets converted to Mg2 plus. So here is the change, means 0 gets converted to 2 plus, that means there is a loss of 2 electron. Okay, so it is the oxidation. And what is the another reaction? Sn2 plus get converted to Sn. So when 2 plus accept 2 electron, then 2 plus minus 2 is equal to 0. So gain of 2 electron means reduction. So reduction at cathode is Sn2 plus 2 electron gives Sn. So the overall reaction, combination of left hand side to left hand side, Mg solid plus Sn2 plus molarity 0.04, 2 electron get cancelled, gives Mg2 plus 0.06 molar plus Sn solid. The number of electrons are transferred by this overall cell is 2. What is the E cell? E0 cell is 2.23 volt, it is given. Now we have tried the formula. So E cell is E0 cell minus 2.303 RT upon NF into log to the base 10 of Mg2 plus divided by Sn2 plus. On right hand side product is Mg2 plus, on left hand side Mg Sn2 plus, where this Sn and this Mg solid, these are in pure form, so their concentration is considered as unity because they are in solid state. Now substitute the values. Concentration of Mg2 plus is 0.06 molar and that of concentration of Sn2 plus is 0.04 molar, and E0 cell is 2.23, then 2.303 as it is. R is 8.314 joule per Kelvin per mole. Temperature is 28 plus 273. N is now 2 electrons are transferred, so N is equal to 2. F is nothing but 96,500. So if you substitute these values, 2.23 minus 0.052. Okay, that is simplification of the terms which get substituted, and your final answer is E cell is equal to 2.234 volt is equal to minus NF E cell. Substituting the value of E cell, F and N, so N is equal to 2, F is 96,500, E cell is 2.234 volt. So your answer is minus 431,162 volt coulomb, because it is the unit of Faraday, it is 96,500 coulomb per mole electron, and N is nothing but mole electron, so that mole electron get cancelled, and what is E of cell? It is volt, so your final unit is volt coulomb, that is nothing but joule. Okay, if we divide it by 1000, then your answer is minus 431.162 kilojoule, and you have to write whether the reaction is spontaneous or not. For important hint is, if delta G is negative, reaction is spontaneous, so your reaction is spontaneous. So in this way we can solve the numerical based on this. Okay, then thank you to Maharashtra State Board of Secondary and Higher Secondary Education, Pune 5, for providing the PDF format of textbook. My YouTube channel is KHARGE. If you like, please subscribe and share the video. So in next video we will see the reference electrode. Thank you.